I'm Sam with SkreetKar 3D. Today I'm going to be demoing the new Revopoint Metro Y Pro scanner. I have it right here on the table. I'm actually going to be using the new wireless capability with the power adapter and using Wi-Fi 6 connected to my laptop. I have two streams going on. I have this webcam as well as an overhead webcam that's going to be able to display the area that I'm scanning. So for today, I'm actually looking at a alternator. This is a 2009 GT500 alternator. The pulley has been removed, but we should be able to get a good and accurate scan of this alternator. So without further ado, let's go ahead and get scanning. So my goal is to be able to show the scan as quickly as possible, and then we'll mesh and we'll go from there. Okay, so if you notice that I probably have some modes turned on, I prefer if you look, the excellent range for the Model Y is right after 230. I tried to go ahead and turn that right there, and then I don't want to capture useless data, so I'm going to go about 350. I like to do that so I'm just not trying to scan the wall, or I'm not trying to scan the table, but hopefully still, as you can see, it's seen all the marker dots, so that shouldn't be an issue. Okay, without further ado, let's go ahead and get this scanning. As you can see, it captured that quite rapidly. Now we're just going to keep going across it. I want to build these frames in. Now I don't have any markers on the part itself. It's simply picking up the markers from my turntable, or this Lazy Susan that's actually on the ground. So as you can see, I'm actually picking this up quite easily. I'm going to turn off to the side. Now I am in cross laser mode, and on the Pro you get 34 cross laser modes. That's why it's actually capturing this really quickly. And I'm also in my trusty, I don't think you quite need it on this particular part, but I've just gotten a habit of every Revopoint scanner I use is to use the dark mode. It's my favorite mode. That's with the Track It, that's with the Mini, that's with the Pops, that's with any scanner I get from Revopoint. I always use the dark mode. It just works for me. I'm used to it. I don't have to fiddle around with exposure settings. I can just immediately get to scanning, and that's exactly what I'm doing right now. As you can see, we're probably a minute in, and I'm able to quickly, and I'm kind of happy that I don't have a cable attached to it. So I'm going to be later testing the mobile device capability with, I think they call it RevoMirror, whatever that application calls. It's basically our remote desktop feature, and we've actually been scanning that way for a while. It's really no different from how we were doing to Track It, and how we were doing with the Metro X. We're kind of doing that as well. Remote desktop to the screen, and having a long USB cable, so we didn't have to have our laptop right there in front of our face. But yeah, this is captured quite nicely. I like to try to walk it on around, but I believe I've captured this quite complete. And right now, I would have already said it's done and probably just stop, but I'm just going to go ahead and try to capture as much. I like the rule of thumb of trying to capture almost 10,000 frames, but I want this nice and green. But I think from what you're seeing, you could already tell I could have stopped a long time ago. Again, we're completely wireless using the USB cable, and I'm going to go as long as I can. I didn't even charge this. I took it out of the box and actually went straight to it. So let's go ahead and do complete. It turns off, which is good. It saves its battery. But yeah, that looks pretty good for what I was quickly capturing. So let's just keep trucking. So I'm gonna go ahead and start a new scan. Let's go ahead and put this guy on its side. You want it to where, yeah, you don't want it to rock. So always give it a good shake. Make sure your pieces are not going to fly off anywhere. I could probably add, I got a whole basket full of these things. I can just probably add as many as I want. These are all, some of these are from the Pro Metro kit, and then some of these are actually just 3D printed and added. Okay, so let's go ahead and continue. Still wireless. Alright, hit play. And yeah, see how quickly that came in. Now, I'm staying in the excellent mode. And like I said, I tried to look how quickly that alternator was able to be captured. I mean, it pretty much got that entire side right away. So let's just keep slow and steady. I like to go ahead and get most of the perimeter. We're going to be using this to overlap and, you know, put them together. So you don't have to try to get too crazy and add extra noise. If you start like trying to scan too low, you're not really going to get good scan data because it's going to be scattered light. So just keep that in mind. You want to be able to scan what you can scan really well. Keep that going, but you don't want to keep just trying to scan like all the way under, even though it's getting in there good. I mean, that's going to be helpful to sync, but I don't recommend just sitting there for 15 minutes trying to get all underneath it. It's much simpler to get as much data as you can here, and then we'll simply just flip the part, get another scan, complete it, and we'll merge it together. So just go ahead and see if we can get this side right here, and where we're at, like 4,000 frames. Yeah. So I'm gonna go over the part. Now, I mean, ignore the markers and that kind of stuff, these errors. I'm wireless right now. So even though I'm still showing and I'm getting 56 frames per second, which is pretty much the same frames per second it says when you're doing the wired connection. I did play with the scanner just a little bit before this. It's a little bit more snappier. There's a slight delay. If I start going like this, you can see there's like a millisecond delay. It's not only capturing data, but it's also doing it wirelessly. I honestly think probably if you were doing a remote desktop connection, it probably would sync up a lot closer, and you probably wouldn't probably tell the difference. So like I said, I try to play with different angles. This is personally how I scan whenever I'm doing my this is how you scan when you're doing the USB connection. So keep that in mind. This is if you're handheld with the PC connection, you're probably going to be scanning in this orientation. You want to be scanning like this, but this is what they defaulted off to, and I haven't made up my mind if I like this better, but for right now, because the way it's mounted to tripod, the battery backup, this is the way we're going to go with it. I'm confident with that. Let's go ahead and hit pause on that. Set the scanner down. Just check out if I ain't got some obvious bad spots. No, I think this looks pretty good. Let's go ahead and hit complete. Now, again, I'm kind of rushing because I didn't pay attention and I'm at low battery. It's flashing right now. I didn't charge it. I literally just powered it up. So, I mean, that's on me. So we're going to go as far as we can, and I have the USB cable if I need to. So let's just look at that. Okay. Yeah. I mean, this is raw point clouds. So just keep that in mind. So now I had this orientation. Now I'm going to be doing this orientation. I kind of want to do the other orientation like this, but you want to find a good spot where it's not going to rock. Okay. I want to make sure it's not, see how that rotates, it kind of shimmies. I don't want it to do that. You don't want the part to ever do that to you. Okay. So how we're gonna solve that is simply grab a towel. Actually, you know what? I think I can probably just get this. Nope. Sacrifice one of these guys. And then I have another one of those I can just put under it. We just want to prop this up to where it's not going to accidentally tip. And it's not going to rotate on us. Okay. That works good. Because if it shifts while you're scanning, you kind of just lost your accuracy. Like I said, just print a bunch of these. All you're needing. But look, I'm not marking the part at all. So that's a plus, right? Right. That's a good guy right there. Okay. Let's keep trucking. New scan. Look at that. Nice and quick. Pretty much all the alternators right there. And there's no doubting that. We got most of it right there. But just nice and steady rotation. We're just going to keep going with it right here. Oh shit. I'm going to take this off because I accidentally bumped it. You can delete a point. You can't add a point. See, it hasn't lost track because I don't see it no more. You kind of have to be mindful that I'm looking at a screen right now. I wouldn't have made that mistake, but just go ahead and remove it. Don't leave it because it's already shifted. So I'm giving you printing device. A scanning device on the fly. Let's just try to get this back half as well as we can, and we want to get that side. So I'm limited on markers right here. So just walk across. I'll walk across. Walk across. We're already at 5,500 frames, so we're doing excellent. So I like to just walk across, slow and steady. As you can see, I'm kind of too close on that top part. It's registering this as excellent, but I need to be up on the top of that. So let's just keep scanning this side. Excellent. Actually, I'm pretty satisfied with the way this is looking right now. And the wireless is working great. I didn't think I was going to be a fan of it. Because I'm not going to try to connect to a phone and have a delayed sync, but I'm going to play with it. But I do like the fact that I don't have a cable that I accidentally can trip and pull the whole scanner down. That's never happened before. Alright, so I'm at 8,000. I think that's probably good. Let's go ahead and pause that. Set the scanner on the front. So Revopoint puts nice rubber stops right here. That is awesome because you can set the scanner down and you don't have to worry about it flopping off. Okay, yeah, it looks pretty complete. I'm pretty satisfied with that. Okay, it completes. Now we can, since it's going to be a new scan, and I don't want to make that mistake again, so I'm going to put it to where I can rub around and not have to, see, I just bumped another one. Okay, quickly look over this. Yeah, easy to casting, and that's not a nasty spot. I would probably go back over on that, but for this video, I'm not gonna, this is not a max effort. This is, I'm gonna try to scan it all in one go, and then we're gonna try to fuse it and put everything together. So now, I wanna do this front half. So, I need to have some pieces. Nope. I keep these around, empty spools. Let's see if we can't get at the center on that. Yeah. Now, I might have trouble picking up dots now, but let's try. Let's just see it. I mean, I might have to kick this off. It might be too far from these dots, but let's just see if it actually still picks it up. Okay. I have another something that I could probably stick on there to actually pick up on that. So, alright, let's go ahead and do another scan. Okay, so I feel like it's picking up those dots, so let's just go with it. Yep. So it's able to see all the dots all the way down here on the tray, and I'm still able to scan the top of or the back of the alternator. I do want to point out I got a zoom button, so I can zoom in. I should have probably done that on the previous scans, but I honestly forgot. So here we go. We're getting the meat and potatoes of this alternator. The only thing we're going to have to worry about is a lot of these pieces are floating in air by the scanner's approach, because it can't see behind the plate that's floated, so it's going to see some of these parts as floating. So we're going to have to be very careful with doing isolation, because it's probably going to be trying to delete those. So let's just move side to side. Okay, try to get this top half. Okay. That black housing behind there. Okay. I know I've scanned this top, but I'm just going to go because I'm introducing other angles. And I'm purposely over scanning and walking in so I can see those marker dots on the table, and not necessary, and then capture the part without having to worry about those marker dots. So that's a plus. So we're getting this. Remember, I was focusing this top. That's the goal of this particular scan, is the scan. Oh, it's freaking out right now because it can't see enough marker dots. So let's just get back over here. That's going to be floating in the air. Okay. I think that's probably good. Always remember to back out first. Alright, I'm going to pause it. Now, this right here was my accident, so let's just use that as a grain of salt. We still got this nice and clear. let's just go ahead and see what we got. So I'm gonna hit complete, and now the scanner should be turned off to save my battery. Let that complete, and then we should be able to come over to the scan. Yeah, I mean, that looks pretty good. So what I'm gonna do is, now I think we have one from every side, and if we have something that's missing, obviously we just need to go back over that side. So here's what I'm gonna do. Let's go ahead and batch process. I'm gonna fuse them all. I'm not gonna do fast fusion. I really honestly don't know what that does yet. Let's just go ahead and do high quality fusion. Well, no, on this case, just do fast fusion. It's recommending 2.7. I'm not gonna do that. I'm gonna do 0.2. Let's just go with that. Let it process this. Now this is the same laptop I was using with the Track It scanner. The tripod's actually standing right here. And actually my Metro X. This was bought new when I bought when I was beta testing the Metro X. So this is I think it's an i9 processor, and then the GPU is a 4070 GTX. So I mean, it's a pretty stout laptop. I don't think they really made the processors much quicker. I think it's a 1490 HX. But I mean, it's a pretty stout laptop, but it is about a year and a half, 2 years old now at this point, so keep that in mind. But it's not super expensive, so if you're thinking you need to buy a a $5,000 laptop, no you don't. And this was $1,500 at Best Buy. You can go to the store. I think you can buy this exact model now. I think it's like $8.99. I've seen it a few times go down to $8.99, so keep that in mind. Buy good hardware so you can do a good scan. I'm probably gonna save my USB power by going ahead and powering off that battery backup, because I only see one dot, and let's just go with that. If I need to rescan again, we can always just power it up. Now, was this optimal? No. I should have planned it a little bit better. I wasn't. If I left the pulley installed, it probably would have been fine. There's enough resistance in it that I could have spun it, but it's just sitting on the stud that the nut's mounted to. So, you have to adapt for what you're trying to scan for. Settings wise, again, like I try to point out, is Revopoint's default will scan from like 200 millimeters to 400 millimeters. But the optimal scan range is usually like 205 to like 300. So I take those helpers out of the way. I will go ahead and shrink that down so I can simply excuse me, I'll shrink that down so it's not capturing bad data. I don't want it set at 400. I'm scanning this and it's picking up this table, it's picking up this wall, it's picking up all this. It's not so much on this laser scanner, but on other laser scanners you do have to be completely mindful on this, because you will encounter bad areas. I know, like on the pop scanners, like the IR scanners are really bad about that, because they'll anything they see, they think, oh, I want to capture that. Laser scanners are a little bit more what's the word for it, determined on what they capture. Like, they're not going to report anything back unless that laser, the sensor picks up a laser hitting that and bouncing back, versus the IR is just it's painting with light and then just scanning everything from there. So we've already got one of them finished, and again, I am honest, and that's 2. I am doing it at 0.2. It was recommended 0.7, but I want to get as much detail as possible. That's how I always do my scans. And to be honest, I would have, if this was a customer part that I need to have it as perfectly as possible, I would probably went into the parallel laser mode and got all the details possible. But it does take a little bit longer. I would say it probably scans more like the Metro X in cross mode, because that, I mean, it adds up. I think the Metro X has 14 cross laser mode, whereas now, and then it had 7 parallel lines. Well, now the parallel lines are 15, which is almost equal to the 14 of the cross lines. But then now you have 34 cross lasers with the Pro. I think if you have the regular Y, it's only 30. You also get the benefit of having full field mode. If you've had their scanners before, their blue light scanners like the Mini 1 and Mini 2, that's basically what full field is. You're literally just blasting blue light, and it's acting like a near infrared scanner but with blue light, and it'll pick you up. I've kind of went away from that, but if you're using the dual axis turntable, and if the part has features that are not shiny or black or red, it'll eat it right up. It'll scan that like perfect. You just sit here and hit scan and let it do its automated thing, and it'll tilt and do. It's a dual axis turntable, so it's going to, whatever you program to it, and it'll get almost every angle that it possibly can without you touching anything. You set this up on the tripod, set it right here, get it framed right, and just walk away. Come back, it's done. It also, I like that method because it's not doing the old style of just blasting and scanning. That's how we used to use the Mini 2s or the mini scanners. We would have it just sitting here, and it would get so much data. Like the point cloud data is huge, but because it literally was taking all those points and it was just rotating. Now it's very intelligent. What it does is it does like 2 or 3 frames. That's it. It'll move it here 2 or 3 frames, move it here 2 or 3 frames, and it'll do this with every programmed motion. It's pretty neat, but it's more well, I mean, it's just very professional. It's very neat how they do it. Me, I don't have many super small parts that fit on the turntable, so and the turntable's right here. So it's this guy. So yeah, I could have fit that on there, but I would have been blocking any marker dots. But if you have a part that will fit on this, like this mouse or something like that, or a turbocharger or anything like that, yeah, that's gonna work out excellent. And that's where buying a higher end. That's why I like buying a higher end scanner or something like that works out. So now let's not waste too much more time. Go ahead, hit OK. Oh wow, I think that looks pretty good. Now I will say they've kind of got a little bit more aggressive with their fusions. They're like dumping data it doesn't trust. So like all the windings inside, I didn't tell it to do isolation. It just pulled that out. Do I wish they were less aggressive? Yeah, I wish they were kind of like with their older software, but they may bring that back. But I think in all fairness, this is probably the best approach, because you don't want to be chasing bad data. You don't want to have bad windings in there and it's just going to show up as noise, and then you're going to think you got a bad scan. So, I mean, I'm fine with that. Yeah, that one picked up a little bit of the windings, but you can see it kind of deleted a lot of it too. So. Now we're just going to do a speed run and try to see about aligning all this. So as you see right here, I was too close. That was too close noise. When I was scanning it, I was probably scanning this portion of it instead of here. And that's just me, literally the second scan I've done with this scanner. I gotta get used to it. And I probably need to play with the settings a little bit more. So, yeah. I'm seeing enough data that I think wherever we have noise, I think it's going to be fine for it to pick up. So let's go ahead and do a speed run on isolation. So I'm going to go ahead and do selection. So You can select the part, invert it, delete everything else. Okay, isolation. See what it does with. Okay. Yeah, see, it's going to delete that connector. I don't want it to delete that connector. It's kind of important. So let's just hit this back. Let's see if I can scale it back, and now detect. And that is 100% a true detection. That is floating in space by the scanner's approach. It cannot see where this connects in there. It cannot get into all the bits and pieces of that, so it thinks it's floating. So that's why I was like, oh well, you want me to delete it? No problem. And if you see this, that is 100% like, I don't know, it feels like welding slag, but I know it's not because it's aluminum part, but it's just pad castings. Go ahead and do that. Get a little bit more aggressive. If it tries to select that connector, I'm going to say no. Yeah, see, we don't want that connector. Let's do detect at 8. It wants that connector gone. Okay, that's fine. It's going to go over here. Let's go to the next one. Okay, that's a bad part, so I don't want to do that. Let's see if I'm going to try this. This is probably like the success rate is very small for me every time I use it, but let's just try it. What this will do is it'll try to just get all the point clouds all related to each other and select just that. Hey, looks like they did pretty well. I don't know if I trust that. I think I'm gonna go with selecting this. Actually, hit cancel, rotate over, and let me do that again, but this time look from the front. I just don't want it to accidentally try to delete like that. Yeah, it's not getting the windings, and it's not getting that. So let's just exit that, and let's just select this. What I'm trying to do is minimize the amount of work I gotta do. This tool works pretty well. What it's trying to see is what's all related. I'm pretty confident with that. Let's go ahead and delete that. Okay. Hopefully I didn't delete anything else. Now it's floating in air, and I'm gonna just go back just to see, just in case it deleted anything. No, it didn't delete anything inside. So okay, that works for me. Hit escape, and of course we got this straggler right here. Let's go ahead and delete that. Delete him. And next. Remember, we're just kind of doing a speed run, so we're just trying to select as much as possible, quickly as possible. So I'm going to try to select this. Nope, that's not going to work. Okay. So now I'm going to do the old trusty plane. Revert that, delete that. So now we should have it floating, and then I should be able to do isolation, detect. Delete that. Okay. Delete those. detection. So now I want to select those. Oops. We're just, like I said, we're trying to do this all in one session. Okay, alright, let's do this one more time. Like I said, it's a hit or miss. It's sometimes, yeah, see, it's too aggressive. It thinks all that's all related, so on that basis, try to get as plain as close as possible. And we use the plane tool. Now we're going to be chipping some of it off, but oh well. Okay, invert that. Yeah, that works. Escape. Alright, so we got that, so now I'm going to do isolation. Let it try to just pick up some whatever the stragglers. There it goes. Isolation, protect. Okay. Isolation, protect. Ooh, no one picked up a bunch. Alright, so now what we're going to do is we're going to go ahead and try to align all these. So I'm going to go ahead and go straight to merge. Now you should go overlap detection. Lasers are really good about not having too much overlap, but we can do that. I've just gotten used to the laser scanners not really needing this. You do need it whenever you with the infrared scanners a lot, because you're constantly overlapping. So let's go ahead and shrink these down. It really is best practices, so let's just go ahead and go through the whole motions. Okay. Now let's go ahead and merge. Now we should have enough data right there for it to recognize. So I'm going to try to do a future alignment. That might not work, but let's just try. You can do a manual alignment, but if you play with it enough, you should be able to get a feature alignment. But if we have to do a manual alignment, we'll do a manual alignment. Like see there, it recognized enough data to capture that. Look at that. Pretty much got the whole case just with those two scans. So now let's go ahead and add another one. Preview alignment. You want to try to do as many as you can at once, because if you merge like 2 or 3 and then complete the merge and then try to add 2 or 3 more, every time it kind of loses some of the sharpness and like softens the part. So, but if you do them all at once, that tax of softening is only paid once. You don't have to keep paying that tax. Now if you have 30 scans, you're going to have to do that. Oh yeah, see? Recognized it just fine. Go ahead and preview alignment. And this is why you want to do a complete all sections scan. Just get as much data as possible, because what you're missing, I mean, you can clearly see. Now I will say I'm not probably going to do a fill hole, just for the simple fact we're only seeing the face. If this was more of a solid part, like this box, if we were scanning this box, I would definitely scan the entire part, because it could be watertight. It's nearly going to be impossible to be watertight, but also it's had to delete most of the windings. It's not saying that it can't see the windings, it's because it's never going to get that winding complete. It's only going to see the windings right here, and then and then when you rotate just slightly, so it's going to be a whole bunch of broken floaters. So if you're using one of the tools to do the cleanup, you're gonna have to choose. You want possible floaters on the surface, or do you want the floaters that are useless that you're never going to get a measurement of? I want those gone. Okay, so I think that looks pretty good. So we got that little blind spot, we got that connector very well. Looks like we have 3 points of data right there. We do still have a little bit of a blind spot right here. There's nothing really I can do about that. It's just, it's so tight. It's literally a it's that tight. I mean, you're seeing on the webcam right now. That part right there, I'm sorry, I didn't scan in there. Now, if I go into the single line mode, probably, but do I need that? If I'm reverse engineering this part, do I need to get in there? No. I need to know these marks 1000%. I need to know these, and that has enough meat that I can justify this is attached to this somehow, and it's probably going from this plane to this plane. It's not very hard to realize what is needing to be done. Like you see, you have that plane already there. Alright, so let's go ahead and generate the model. That was not very smart. Let's just go ahead and say it out loud. Okay. Alright. And these come in handy. They're clear. Clear spool holders are your friends, but the clear ones are great because I don't care what kind of scanner you have, it's not going to see glass. It will pick up some areas of it. If there's, like this has got heavy dust on it, it will pick that up. But more than likely, if you're trying to scan a part on this and you're focusing on getting the exposure correctly for whatever the subject that you're trying to scan, it's going to scan that and not scan this at all. In fact, I don't recall seeing this in After Diffusion. I think the software went ahead and saw that it was terrible, and it went ahead and deleted that from the jump. So we're merging now. So we're taking all 4 point clouds, putting them together. And we're going to go ahead and see about this finishing, and it says it's almost done. But you can actually see the painting or the decals that are still on this that says like live long or springtime or something like this. This is literally from, okay, well, I say that's a pretty, yeah, we got some windings. Not all the windings, but we got some. We got a good bit of noise right there that I don't really like. Let's go back to merge. I'm gonna check this out real quick. Okay, that's correct. That's correct. Okay, so that's not merging correctly. Notice what I just saw. If if you look at this one, this completed merge, it's like a 6-sided nut. That's not right. So I need to pick up on that. So let's go to, let's just take that off. We want this guy first. We want a preview alignment. Sometimes it helps to just change your order of fusion. I mean, of merging, and it'll align it a little bit better. So now let's see if I don't have a weird looking. Yeah, see, it's still. That's not right. Okay. These all seem to align correctly, but that last one, it's getting confused on this nut. Oh shit. Okay, so it is aligned correctly, but you remember whenever I put it on the turntable, I was rotating it, so it is lined perfectly. This is not lined correctly. So at a certain point, so you saw me modifying the part, and I love that. That's a good point. I didn't realize that whenever I had this right here like that, I was probably rotating it just slightly enough. So that's it. That's why it's recognizing a lot of the frame correctly. But the nut was off. So I'm going to go with just this because looks like we got a good portion of everything. Let's just try to make a merge from this and leave that one off. It is what it is. That was just a dumb monkey mistake. I think I remember probably doing that one time. I was probably talking and I rotated it. So that's why it was lining these up, the features, perfect, but the nut was like, no, you need to have six sides of that nut. So be mindful. Easily able to make that mistake. Just like when you saw me bump one of these, take it off. Just take it off. What it'll do is it'll look at the dots it knows, and if it sees an extra dot, because I am not in global marker mode, I'm in just regular marker mode, not global. It would have just seen 2 extra dots. So if you accidentally move one, do not keep scanning. Take that sucker off. Take it off completely. Now, if it's not picking up in that area no more, then you need to kind of make a decision of either starting a new scan or scanning what you can. But you do not want to skew your own data by doing that. Okay? Okay. I mean, I think that's, I don't know. I choose to have non-bad data versus having the good data. Okay, so now let's go ahead and go to isolation. Again, I don't think I'm going to use this one because I think it's correct, but I think I skewed it by rotating it. So let's not do that. Let's just look at this one. So we're purposely deleting one of the scans. I'm not using this scan data at all. Looks pretty complete for my hand. Now let's see what this guy does. What does this one look like? Well, it's not the bottom anyway. Oh, that sucks because it's like the perfect top. Okay. I got an idea. We can use that. Watch. this is what I'm gonna do. I'm gonna take this guy completely off. Or just delete him. Now we can go back to merge. And we can do down, 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 down. Picture alignment. This was, if we saw me zoom in, it was showing it as it was floating in the air anyway, so we're going to get more data up top, and we're going to get more of the front face. I want to get this as dense of a scan as possible. That way we can get aggressive with the meshes, and then we can just look at everything else. So this is probably going to be an hour-long video. I think my mic is still on. Yep, mic's still working. Alright. Hey, look at that. I don't have... Yep, I don't have all that junk. And I just kind of got more of that area. More of that area. Okay, generate model. And what we'll do is overlap detection and all that kind of stuff. So just don't make the mistake of touching the part post your scan. Now I do have my Metro X still, but this is pretty neat. I mean, I will say the build quality is great. I mean, it looks good. The vents look top notch. The overall look of this scanner, I mean, it looks and feels legit. They have extra cooling fans. I think the Metro X had a cooling fan as well. But you have cooling fans, you have vents. There's vents here. Well, no, there's no vents there. It's just vents on this front half. And RBG camera for, you know, doing your full color scans. And this my full disclaimer, I'm never going to do that. I just need to get test type of data to, you know, spin it up in CAD. If they need to do like a alternator delete bracket or an alternator relocation bracket, they need to know those points to the T. They need to know they need to know the thickness and the angle. So most of these actually have angles baked in. That's how you align your V-rib belts. What they'll do is they're not perfectly straight, because if they're perfect excuse me, if they were perfectly straight, then you'll never get these. Every vehicle is different, so what it does is it's tightening in. If you see it, it's slightly bent in. So alright, looks good. We don't have 6, no way, we don't have a 6 nut bolt. Alright. Excuse me. Alright, I think we're gonna go with mesh number 3. Looks good. Alright, we're gonna do isolation. Let's see if it picks up anything. It did. Now we can get a little bit more aggressive and go back to the default 15. I do not want to. All that work for that nut, I'm not gonna do that. Still not gonna do it. I think 4 is our happy spot. Okay. Alright, cool. I'm going to do overlap, detecting at 0.44. This is where you really need to do overlap detection and clean up. Okay, just keep going detect. Basically, you keep doing this until it barks at you. Still not barking at me. Still picking up stuff. We go smaller. Picking up more noise. Nothing. Check. And you'll see there's an error that pops up. That's what you want to keep going. Keep going until it barks at you. Doesn't want to do it now, I guess. They may have taken it out of the software. Okay, that's enough of that. We're gonna do high quality mesh. Oh wow, it's recommending. Nah, I'm not gonna do 6. We'll do 6.5. I think I fused everything at 0.2, so I'm gonna mesh at 0.2 grid. Let's just go with that. So it's gonna take 2 minutes. In that time frame, we can kind of go over this scanner. So the battery, this is a lot more stout than their old battery backup, their mobile kits that they used to have. It's a nice. I was thinking it was metal, but this part's metal, but this is actually plastic, but it's a heavyweight plastic. I think because you can mount, it's got a tripod mount on the bottom, so I don't know if you're mounting it on a tripod wirelessly. I don't know the thinking for that, but it has a tripod mount and it's rubber here, so because it holds the threads. But this is legit. So let me just mount that on the bottom. But and it comes with a short cable for you to just power on that. But normally I'm going to be scanning like this. I like being able to hit the buttons and do my gain and zoom. When you're doing it this, it's not as convenient. When you're scanning like this, it's not as convenient. So I may model a way to have the battery backup like straddle the side and it's scan like normal. So that's to be determined. But so far, I mean, it's a pretty looking scanner. I'll give them that. The gold ring, the gold logo, the gold buttons look pretty. They look pretty legit. I like it. This map you can ignore. This is when I was scanning with Metro X on larger parts, but I was hoping that it was not going to pick up on it. I think we got lucky that it was only focusing on this. But you could have got yourself in a pickle if you had marker dots on the table and this is turning, because then it's going. This is moving, but this is not moving, and I could have easily got the scanner confused. And heck, that part that we actually started losing scan, that might have been actually these dots right here on the table that it was being picked up on. This is just because on larger parts I'm taking this completely off and I'm just laying the part here and just scanning it. And these are actually the foam pads. These are the calibration pads for, oh boy, that's heavy. Calibration boards for the Metro. I mean the Morocco. This is the far mode pads. Hardly ever have to use them, but I'm not really damaging them. So what I did was I have a couple of these because I had a few Moroccos. Just took it out, spray painted it black, and then went to town with it. Alright, well, here's our finished mesh. I mean, it's right here. Keep in mind, I did not clean this at all. This has probably got, you know, 60,000 or like 200,000 miles, if we're honest. But this was used. This is not the one that came off of my car. This is one I got for a spare to rebuild, because the factory ones are they die a lot. When you have a supercharger and you're spinning a supercharger, these are the first thing that die, because you're spinning all of your accessories oversped to do, you know, like high boost, and at 19 pounds of boost, this thing is being spun well over its limit, and it's just simply wearing out. So if you have a blower car, you're going to eat alternator, so you just got to plan on having extras. So I literally just got this to take apart, and I'm completely going to rebuild. So I didn't clean it, didn't do any spray, didn't do any markers on the part at all. So just keep that in mind. But yeah, those mine. But I think I definitely could. I have enough to reverse engineer any mounts. So you got your. So we have a little bit of noise right there. But I mean, is it noise or is it dirt? I'm probably thinking dirt, because if you see that area right there, it kind of coincides with that. So either way, we got a complete scan of I mean, that stud looks good. It's floating. So don't do an isolation right now, because it's going to try to delete it. But I mean, this is a lot of blind spots, but you have those scanned pretty easily. Okay, well, that's SkreetKar 3D. If you enjoyed this quick, well, it wasn't a quick tutorial overview with no skips, no fast forwarding, just completely, if you're going to take this and try to scan it with the new Y Pro. I shouldn't be touching it with my nasty ass hands, but anyways, I don't recommend you touching your scanner with dirty hands, but I just did it. Oh well. Okay, well, there we go. Alright, SkreetKar 3D. Subscribe and just follow this playlist, and I'll have more scans coming later. Thanks.